So let me share my screen for those of you that are here, and I'll get started. And then we'll go from there. Today we're doing, oh geez, lost it on the iPad. Today we're doing 6.1. So let me figure this out. Why is it not? Okay, here we go. Share screen. Yeah. Oh, and let me just give me a moment to pull up the chat, see your lovely faces. And I never really I thought I allowed closed captioning, but if you can't do this, it's an ACC thing because there is a setting in our Zoom, like the ACC account, that it might be blocked. So somebody just said they may not be able to hear well. I will do my best to write everything. I will probably explain things, but I could put headphones in if that's louder, or I could, yeah. Okay. So Jakob saying, yeah. Okay. Oh, thank you so much, because I can't figure out the closed captionings then, because I thought I selected it and you're not able to. Okay. So Jakob is saying he knows. Well, would we be able to, do you know if we'd be able to do it in class? Like today or no? Oh, I can't. Okay. All right. Well, if you want to share that with me, I would need to end the meeting and you all come back. Is that okay? Well then maybe I mean, it could be worth doing this, but maybe at the end of class, Jakob, if you could send me a little, whatever she said of what settings she selected or how she did it. When I end the meeting, I can go back into my settings and make sure that's turned on. Yeah, on the Zoom. Yeah. So I log in on Zoom and I thought I selected it, but clearly, I mean, my computer did crash over the weekend. I don't know if it would regenerate whatever the default settings are, but I will try to do this. And yeah, I can talk to you after class. 5.7. No, so we're skipping around. So German asked a question. So we did 5.5 and 5.6. We're not going in order. It's going to be 6, 1, 2, and 3 this week. And then 5, 7, or 6, 5, and 5, 7 or something next week. So we're just out of order. So I apologize. And if you didn't print this, if you want to go print it now, please do. If you can't print it now, then just write this on paper, like on blank paper or something. And I will post these notes and you can always copy it over.
Recording in progress.
But okay, so again, today we're doing 6.1, and it is mostly, oh dear, I did charge my pen, so let's just hope this doesn't fail me now. It is going to be trig identities and exploring, proving them, using them to solve a problem or something like this, right? So it's actually pretty exciting. Or it's nice when it works out. So hopefully you feel the same way that I feel when we get here. And so this first chart, basically all here, it's things that either you already know or maybe you haven't seen or don't remember, but things that we've seen before. And it's just reminders. So I won't really read through everything, but here you have your reciprocal identities. So you remember that cosecant is 1 over sine. Sine would be 1 over cosecant then. Same thing with secant and cosine, and tangent and cotangent. They're all reciprocals of each other. Then it's the quotient identities. So tangent is sine over cosine. Cotangent is cosine over sine. So they are also reciprocals here in terms of sine and cosine. You could write them. The biggest identity that you will have to memorize, and I would say, you only need to know this one, is going to be sine squared x plus cosine squared x equals 1, because from this you can get the others, right? So if you take sine squared plus cosine squared, and you divide everything by either sine squared x or cosine squared x, you get these two, the next two. So if you divide by sine squared x, you get this first, because sine over sine is 1, cosine squared over sine squared is cotangent, and then 1 over sine is cosecant. And then if you divide by cosine, you get this one. So I guess I'm not writing all that out, but maybe somewhere, let's see, maybe I'll write it somewhere for those who can't really hear. So.
Hey, Professor, could you make it a landscape?
Oh my gosh, yes, yes. And Jakob just said this. I'm so sorry. I forgot. Okay. This looks much better, right? Hopefully. So again, and maybe I'll just write it in like light colors or something. If you divide this by sine squared, divide by sine squared, divide by sine squared x, it gets you this right here, right? If you simplify. If you divide by, instead, if these were all cosine squared, I don't really know where to write this. Maybe, maybe if this was cosine, 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 you'd
Sorry,
get.
but can you use the other color or darker one?
Oh, you can't see this. Yeah. Okay. So instead, if this was cosine, cosine, and cosine, like squared x, right? If you divide by that, then this becomes this second identity. And so if you just remember this first one, right? If you just remember this, then you know all of them. So that's why I'm saying this first one's the most important. Then we have our even and odd identities, which I mean, everything is odd, except for cosine and secant. These are even, right? Everything else is odd, right? So, so we're going to use these, and same thing with factoring. Hopefully you remember this too. This is not trig, but this is from a while ago. We have the difference of squares. So if I had like x squared minus 9, 9 is 3 squared. So we could break it up into x plus 3 times x minus 3, something like this, right? So maybe here's an example. And then perfect square trinomial, I mean, that's just distributing a plus b squared. And then this does not factor, right, in real numbers. And we're only concerned about real numbers. Okay, so this first part, we want to factor. It says factor cosecant squared x minus 1, right? We can write this as cosecant x squared minus 1. Okay. And I mean, this could be 1 squared. So you could think of this as the difference of squares, where my a is cosecant and my b is 1, right? So now I can rewrite this as cosecant x plus 1 times cosecant x minus 1. And we're done. We factored. We don't have to solve. I mean, we could, but it's not asking us to, right?
It can't be only sine square of x, like Pythagoras.
What? Sorry.
Pythagoras.
Oh, well, yes, but it's asking to factor. So yes, I see what you're saying. If we use the Pythagorean identities above, right, we could rewrite it as something else. I think that's what you were saying. But I think it's just cotangent. Yeah, I think it's cotangent squared, not sine. But you could also write it as 1 over sine if that's what you were saying. So, but this specific problem just wanted us to factor. So now simplify the expression. we want no fractions in our answer. So, yeah, okay. Thank you so much, David, you're good. You can come in and out, that's fine. So for this one, I'm going to change everything to be sine and cosine, and then I'm going to try to simplify and not have any fractions. So I'm going to start by cosecant is 1 over sine x, then times cosine squared x, and then like this stays the same, and then secant is times 1 over cosine x, right? And this is going to be, so one of the cosines will cancel, this one, and then we're just left with, maybe it was this one. We're just left with x in the numerator and sine x in the denominator. And it says no fractions though, no fractions. So this equals, so you can scroll up and see that this equals cosine over sine. Oops, sorry. This equals this one here, right? So this is cotangent x. And there's our answer. I'm going to do the same type of thing here for the next one, except, well, you have options. You could change it all in terms of sine or cosine, but I see a fraction already, so I want one common fraction. So I'll write get a common denominator. So we have one fraction, and then we can simplify the one fraction, right? Then simplify. And I'm writing the steps. Hopefully this is helping the people that can't hear so well, or can't have the closed captioning for today. So what I want to do is I need my LCD here, my least common denominator, is tangent squared. Because the denominator here is tangent squared, this is just 1, right? So now I can multiply this here. Ooh, that isn't good. I can multiply, well, I'll rewrite it. So let's take secant squared x over tangent squared x minus, and then 1, and I'm going to multiply this by tangent squared over tangent squared. Because that's just 1, but it gives me the same denominator. So I'm multiplying this just by 1. And then I can rewrite this to be secant squared x minus tangent squared x, all divided by tangent squared x. Now, this is where you could change it sine and cosine and try to simplify, but the trig identities above, so remember we're using those here too. So looking at the trig identities above, secant minus tangent, there's a secant and a tangent in here. If I subtract tangent over, it just is 1. I have secant minus tangent is 1. So this actually equals 1 by the identity above. And so I'm going to get 1 over tangent squared x, right? And I want no fractions, remember? So this just equals, remember, 1 over tangent is cotangent, right? So this just equals cotangent squared x. Wow, these both were cotangent. That was like a silly coincidence, it seems. And then the last part of this question, the simplifying, part C, for this part, we're going to try to factor a little bit because there's a lot going on, right? So I see a cosine, a cosine, a cosine, and a cosine. I see cosines in every term. So I'm going to factor out cosine x from both the numerator and the denominator so that I get something a little bit simpler. So let's see what that looks like. So I'm going to get cosine x, and then I'm left with cosecant squared x minus 1, all divided by cosine x, and then cosecant x plus 1. Now, I mean, the first thing you can get excited about is canceling these out, right? But those of you that look at this and you want to try to use the identity first, that might be good if you can use the identity for the top. But notice how these are kind of matching. So like cosecant squared, but I have cosecant. I think to myself, okay, maybe it's nice if we do what we did in this previous here and we factor. So if we take this answer, because that's just exactly what we have here, we'd get cosecant x, it doesn't really matter what goes first, but plus 1, times cosecant x minus 1, all divided by cosecant x plus 1. Now, what's really nice about this is these cancel, right? And if you tried the identity first and you really couldn't figure it out, it might still work. But if you tried the identity first and it did not work, then you would go back to this, this step and try and say, okay, what else could I do? And so my final answer here is just cosecant x minus 1. You can't simplify that. There's no squared, you just leave that the same. And so the way that I knew to do this as well, so maybe a little like hint when you see something like a squared minus 1 over a plus 1, where your a is, whatever it is, like this is what I saw. I saw cosecant squared minus 1 over cosecant plus 1. And the cosecant x is like my a. And so I thought, oh, I could factor this a plus 1, a minus 1, and cancel that denominator out. Okay, so this is kind of what was going on here, like this guy, right? Okay. And please stop me if there's questions, or I do have the chat up. I'm trying to be good about this, and I really apologize that the closed caption didn't work. I clearly am technologically challenged. Okay, so now new types. So these were just these types of problems were simplifying. Okay, now we're going to verify the trig identities. So using the trig identities, we will be given an equation, like something equals something else, that looks maybe complicated, but then we're going to rewrite them using those trig identities or the even and odd functions and show that they're actually equal, okay? Now, these are the rules, and granted, okay, these are the rules, but if you did something a little different, but it still was good work and it was correct, I might not be mad about it, but these are the rules. So let's go through this. Nothing crosses over the equal sign. So whenever you're verifying, you never if we have, and ignore, don't write this down, but if we have, give me a sec. If we have, x squared plus 5 equals 0, sometimes we'd subtract 5 first, right? And then solve for x, right? But we are not going to do anything. Nothing crosses the equal sign. So we are not going to do anything like that for these types of problems. And And in addition, you do not want to clear the denominators, because sometimes, and what else? You do not want to cross multiply, because like, and I'll say etc., but because this is solving. If you cross multiply or you clear the denominator, you're solving or you're simplifying, you're not verifying. So when you're verifying, we do not want to do these things. And I will show you we'll do a bunch of practice problems. But you can see too, so this is not like solving an equation, and I'm just reading this here. You do not want to do things to each side. It's a little different. So you're going to work with one side of the equation at a time, usually the more complicated side, and you'll keep the other side the same. Now, again, I would say, and you'll use the identities, or, work both sides to make them equal. And if you're like, what? I mean, I will explain this. But typically this is what we'll do. Work with one side of the equation, the more complicated side, and you get it to equal the less complicated side. Okay. It is very important to show each step. Right. And you are then simplifying. You're not solving for X or anything here. So keep that in mind. Because we are verifying the identity. So we are not solving for anything. Okay. Oh, I missed sorry, there was a chat and I missed it. I don't remember what I said, but I'm sure it was kind of funny. Okay.
Really challenged.
Oh yeah. Yeah. There we go. Yeah. Technology. We all are. Thank you. I appreciate that. Some days I'm really good. Like, some days I'm really handy around my house. I don't know. Other days, nothing. I got nothing for you.
Yeah, I had a bad day technologically. Yeah.
Oh, see, so you get, okay. Well, I'm very sorry to hear that. And, we all have these days.
Yeah, it's no biggie.
And hey, tomorrow will be better. That's what that means. So that maybe there's a silver lining there for you.
Sure.
I spent like 8 hours putting together a desk for our office at our house. And I mean, I literally spent probably 8 hours, like I think 6 on Sunday and 2 Monday morning. And I mean, it's a monster of a desk. Of course, I'm not at it right now, but man, I felt like I wasted my time, but I was like, you know what? Someone probably would have charged me like $300 to put that together. So, so there we go. Saved myself a little money. No, but okay. And got blisters on all my hands from like screwing in like every piece, but okay. So let's try to verify some of these. These are the guidelines. Again, I mean, this is helpful and we could read through it, but maybe just doing some examples will be good, right? Okay. So the first one says verify the equation is an identity. Okay. And look at this crazy equation. So we have cosine of negative x, secant negative x plus tangent negative x, cosecant negative x equals this. Okay. A lot happening here. First thing first, I mean, I'm going to look like, I don't want any, I see a lot of negative input. So consider even and odd identities. So let's first just change all of that, because I'm not interested in having this negative X inside. I know that's not what we want. So let's do that. So the first step is going to be like rewrite the left-hand side. So left-hand side, this stands for, maybe I'll just write this over here. Okay, LHS will be left hand. I might write this a lot today. and RHS will be right-hand side. Okay, so first we'll work the left-hand side, right? And we'll say cosine even, these are both even. Secant is 1 over cosine. So these are both even. So I just get cosine X, secant X. I don't, none of that, or I don't even need the parentheses. Let's not even do that because cosine X, secant X. Okay. Then I know this is odd tangent and cosecant is even. What's it related to? No, it's sine. Sorry. So it's odd. Everything is odd except for secant and cosine. So odd. So what this means is I get plus negative tan X times negative cosecant X, which, I mean, it kind of is nice because negative times a negative is positive, right? So now I'm going to rewrite this again, like I'm writing it again in terms of, so cosine X, now secant is 1 over cosine X, because I want to simplify. So I rewrote it. And now I'm looking, if I'm looking above, I did the negative input, even and odd first. Now I see a lot of different trig functions multiplied. So maybe convert to sine and cosine and then see if I can get the right-hand side, right? So and you could think of it like this, cosine over 1 times 1 over cosine. That seems nice. That'll simplify well. And then tangent is sine X over cosine X times cosecant, which is 1 over sine X, right? Okay. So what do I get here? Well, this right here, these both cancel, and this gives me just 1. Because I get 1 times 1 over 1 times 1, okay? Plus, over here, the sines cancel, I get 1 over cosine X. Okay, now we've simplified a lot, and this looks good, but I want it to look like this. So I want it to look like the right-hand side, right? So it pretty much does, but just to verify, I mean, we could say this equals, so this is the left-hand side. We've just simplified it to be this, and it equals 1 plus secant X, which, okay, is secant X plus 1. You don't, the order, I know, I understand that doesn't matter. And this equals the right-hand side. So check it off. We verified. Now we're happy, right? And yeah, Miranda says you put a bar cart together once and took a selfie because you're so proud. I wish I took a picture of all the pieces of the desk before I started, because there were like 2 different boxes, 48 steps in each box. Like, it was ridiculous, but it's a really nice desk. And once it's like a L-shaped desk, one day I'll be at it, for class. And it has like a standing side feature. It has drawers. Like, it's nice. But yeah, good job, Miranda. I would be proud as well. We've got to be proud of ourselves. Okay. So we just verified this whole long, complicated thing, and it wasn't too bad. Wait, sorry. How are tan and cosecant positive? Thought they were odd. Oh, okay. So let's go back. David, you're totally right. But let me show you what happened here. They are odd. So it was negative, but it was multiplied together. So when I multiply a negative by a negative, just gives me positive. Yeah. Okay, cool. Good question. Okay, now let's try B. So now we have this actually, to me, this looks just crazy. But we're going to end up getting it to be 2 tangent of X, which is cool. Well, hopefully, right? If you didn't, I mean, it will rarely be the case that it's false. But in this case, it says verify that it's an identity, so it should be true. But if you get if you ever get that something is false, I think it will say like, determine whether this is true. And then, maybe it's not. And it would be obvious. You'd get something like crazy different and it wouldn't even be close. But anyway, so we're verifying for now. So looking at this one, I've got like, oh my gosh, what? No, here. Okay, sorry about that. I've got like all of this going on and I don't know what. If you can graph to verify. I mean, yes, you could graph them both like in Desmos or, and verify this, but on a test or a quiz, you have to verify with the identities, like algebraically. But you should be able to like graph these in Desmos and it should be like the same graph. So that's a good question. Okay, so I want a common denominator for this guy. And basically they're exactly different. So I need to rewrite this. So I'm going to rewrite it and we're going to get a common denominator. So first common, I can't spell, common denominator. So to do this, I rewrite the problem, secant x minus tangent x, right? And what I'm going to end up doing is multiplying I'm going to end up multiplying by 1, but like some fraction, that's the common denominator, minus 1 over secant x plus tan x. We're going to figure out in just a moment. So times, like, okay, I'm leaving this space pretending that I don't know. And remember, we're working only on the left-hand side for now. We're going to work the left-hand side, and then we want to get it to equal the right-hand side. Now, just a little side note for you here. So if you have 1 over a minus b minus 1 over a plus b. So that's like think of this as a, this is b, right? The LCD, so the LCD is going to be a minus b times a plus b. We have to multiply them together, right? Because there's nothing else in common here that we can figure out. So like if it was 5 and 2, you just do 5 times 2 and it's 10. So this is how we're getting the LCD here. And so what I'm going to do is multiply the first one by secant x plus tan x, secant x plus tan x, because I have minus already. So I'm missing the plus. But over here I have plus, and so I need to multiply by the minus, secant x minus tan x, secant x minus tan x, right? Okay, so perfect. Now notice that my denominator, this is my denominator, these are exactly the same. Different order, but they're the same. So same, I'm going to put same denominator. I'm trying to take notes for those people that, want all this. Okay, but now I can rewrite this all. I'm just going to rewrite it as, so 1 times this is just secant x plus tan x, right? And then minus, so this was the first part. So this was, the numerator here. Then I'm subtracting the numerator here. So, and I'll write it all as one fraction. So let's do that. Subtract secant x minus tan x. We'll simplify that in just a moment. All divided by secant x plus tan x and secant x minus tan x. Okay, you can write it in whichever order your heart desires, minus and plus, right? The nice thing is, this is going to be, when we multiply, it's a difference of squares. It's going to be a difference of squares. So now I distribute this negative, right? So it'll be like minus here, but turn into plus over there. I'll combine the top, so rewrite the numerator. So again, my left-hand side is now equal to, okay, I have secant, or maybe I'll write it one more time for you. So secant x plus tangent x minus secant x plus tangent x. Okay, so I see some stuff will cancel. I can see like the secants will cancel, right? But I'll keep going. And then in the denominator, I'm going to actually multiply this all out, right? Ooh, this to this to this, that to that. This to this. Okay. Okay, that was maybe way too confusing. This to each of these, right? And then this to each of these. That's better. Okay, so I'm just distributing, and I'll get secant squared x for the first one minus secant x tangent x, but then plus, well, tangent x secant x, and then minus tangent squared x. Okay, so how nice, these are going to cancel, and the secants in the top cancel. And so now I'm going to get 2 tangent x. It's looking more, okay, that's almost, we're almost at the right-hand side, over secant squared x minus tangent squared x. Okay, this tells me, like, this is an alarm, like this must be a trig identity. It must be, but we'll check, because then we've got, you know, if that's a trig identity, then we've got this and this matching, and we're good to go. So to double check that, I might just say, okay, I mean, you could write it, or if you just scroll up to the, or, you know, go to your previous page or 2 pages ago, I can see here, I've got tangent squared x plus 1 equals secant squared. So if I subtract tangent squared, I think that's what we have here, right? We have tangent, yes, secant minus tangent. And this is going to equal, this is a Pythagorean identity, and it's equal to 1. So my final, so my left-hand side, I finally have 2 tan x over 1, which equals 2 tan x, which equals my right-hand side. Good to go. And these problems are a little bit crazy, but I promise you, you know, we'll make it through. We'll be all right. And please stop me if there's questions, or I know I'm seeing the chat for the most part, but you know, if I don't want to go
for
through
each step, should you know what the process was for that step? Because I think in the homework, when you verify, do you have to say, okay, this was algebra, this was like an affinity?
I actually don't know if you have to say, I mean, in the notes, like, or on a test, I don't care.
Right.
In the homework, if it does make you say,
Like what you used.
yeah, like what you did, and I'll consider that too with the grades. Like if for some reason that makes it really hard, and all your homework grades are bad, I mean, I'll like definitely just send me a message, or I'll notice once I sync them all up, because I have to do it kind of manually check, because the syncing is a little weird. But once I do that, if I notice that like nobody got, you know, a perfect score, or like it just, if it was like that, I don't mind just updating those grades. Because to me, like, although it's good to know, like you said, like what you're doing, like this is distributive property, or this is, you know, adding this is a trig identity, but you know, as long as you're showing the work, that's important for me.
Gotcha.
Yeah.
Okay.
So thank you. And so what's kind of cool about this, which is a nightmare for grading, but is that there are different ways that you can verify. So like I'm doing it this one way, right? But there's definitely, you know, maybe another way that's more difficult. Maybe someone finds an easier way. Maybe they see the trig identity sooner. Like there are multiple ways to verify all of these. However, some of like I'm doing the most typical one,
Mhm.
and potentially maybe the easiest one as well. But yeah, so keep that in mind, everybody, that if you in the homework, like you find that you do it a little differently, or you do it and it's verified, but like the book wants you to do it a certain way, right? So just keep that in mind. It might be that you should refer to your notes and look at these rules that we went over here, because that might be, and same thing with like the guidelines and the rules, the book might be looking for that. So just keep that in mind when you do your homework.
Okay.
Okay, awesome. So let's try part C. So I have cosine over secant plus tangent equals 1 minus sine. So the more complicated side is the fraction side. So I'm going to start with this side. So start with, I mean, it'll almost always be the left-hand side, but you know, just the way that we do this. But start with the left-hand side. So I have cosine x over secant x plus tangent x. And so far, I mean, I am really not sure where to go with this. So I either, like my first thought is maybe change everything to sine and cosine. But then I still have this addition in the denominator that's not nice. So my second thought is, okay, I see secant and tangent, but they're not squared. So I think, so here's my thought bubble, maybe. Can I get a Pythagorean identity from this? Okay, this is what I'm thinking to myself. And if you look before, I mean, this is kind of nice because I had this denominator. I think they're doing this on purpose too. And these are a little bit harder, probably similar to your homework to figure out, but on a test or something, it'll be kind of obvious, like what you should do. And I'll review that like prior to it. It should be better. But I see secant x plus tangent x up here. And I know that I multiplied this plus, maybe I'll highlight. So we multiplied this by secant minus tangent. And then we got something really nice. Like when we multiplied, we got this and it was just 1. So I think if we do this again, the numerator might be messy, but we'll solve it. You know, we'll simplify, but the denominator is going to be 1. And this is what we want. So whenever you see, I think it's in the guidelines too, potentially, whenever you see 2 terms in the denominator, multiply by the conjugate. Okay. So here's what we're going to do. We're going to try that out and see kind of what happens. So we're going to multiply the top and bottom by secant x minus tan x over secant x minus tan x. And remember, when you do this, it's like we're multiplying by 1. So it's going to look different, but we're not really changing anything in the problem. Okay, so let's see. So then I get, I'm gonna distribute this to both of these, right? So I get cosine x secant x, and it'll look messy for the moment. Cosine x tangent x, then divided by, I'm not gonna multiply this out again because we know what this is, but you're multiplying these, you know, you're distributing everything. At secant squared x minus tangent squared x, because the middle terms cancel. This is the beauty of the conjugate. So maybe I'll write multiply by the conjugate. And now this is an identity and it's equal to 1. So I can basically just cancel it out. We'll just say like, and this is a 1. And I'll say, now I have that the left-hand side equals cosine x secant x minus cosine x tangent x, right? And now I see a bunch of different trig functions. So looking back at the guidelines, I'm going to say, okay, I see different trig functions multiplied, convert everything to sine and cosine and see if we can get that right-hand side to happen. So I'm going to convert the sine and cosine. Oops. So like this is 1 over cosine x. This is sine x over cosine x, right? So when I do that, I get cosine x times 1 over cosine x. So like these will cancel and become 1. Minus cosine x times sine over cosine. And again, these cancel and just become sine, right? We just have sine. And so I get that this equals 1 minus sine of x. What was my right hand? Oh, look at that. This equals my right hand side. And I verified. So I'm feeling good, right? Okay, and this next one, I have to say, this next one looks crazy. And first thing in my mind, I'm going to just put this little caution for you all. Do not, that's like, looks like donut. No, let's do not cross multiply. So cross multiplying would be for solving. That is for solving, not verifying. So just keep in mind, that is a solving technique when you really want X by itself. But in this case, that would make it a little bit confusing, right? And again, like I said, there's not a wrong way. You could cross multiply, make it really complicated, figure it out. Cool, but it doesn't really help you, right? It doesn't help you in a sense of get you closer. It adds more steps to your work. So again, we're going to start with the left-hand side. And we're going to say we have cotangent x over cosecant x minus 1. Now, I see something in the denominator that I can't change. So again, I'm sorry for scrolling, but I see 2 terms in the denominator. Maybe I see, oh, that's, okay. I see 2 terms in the denominator, so I see conjugate. So I know I want to get conjugate here. So let's, what is the conjugate? The conjugate of cosecant x minus 1 is cosecant x plus 1. You just change the sign from minus to plus or plus to minus. So here we multiply by the conjugate. Okay. And this is going to make it look a little bit nicer. So let's see what that is. All right, cotangent x, cosecant x plus cotangent x, because this is the top. I just distributed this, right? But then the bottom, maybe I'll give like 30 seconds or a minute. Try to multiply the bottom yourself and see what you get. So you're going to do the cosecants, like each of these, this here, then to 1, then 1 to cosecant, or -1 and -1. And see what you get. See if you can figure out the identity or not. Maybe it's not an identity.
It's just one of the common factoring formulas.
Is this a common factoring formula, you mean? Or
Yeah, that pattern is just one of, it's not a identity, it's just one of the common.
Oh, no, right. This, yeah, the
factoring.
pattern is a common factoring formula, but the answer you'll get when you multiply is an identity.
Right,
Yeah,
yeah,
somebody-
definitely. Oh, okay,
oh,
so what
okay,
you're saying,
sorry.
yeah, if you find the identity
Yeah.
after the, okay, yeah, sure.
Yeah.
Mhm.
So, okay, so somebody did type in the chat, and maybe hopefully this gave you some time. So you should get cosecant squared x, right? Then you get plus cosecant minus cosecant, they cancel out. Then you get -1. Now, which identity do you use? Pauline said Pythagorean, well, they're called Pythagorean identities, right? So the Pythagorean identity that we use here is the cotangent squared x plus 1 equals cosecant squared x from above. This is from like 1 or whatever, right?
Mhm.
So this is the one we use, and if I subtracted 1 from both sides, this is what I see, right? So sometimes you got to do a little manipulating, but what you want to keep in your head is if you see sine squared and cosine squared, or sine squared with 1 or cosine squared with -1, you know it's related to that. If you see cotangent cosecant squared, or cosecant squared -1, cotangent squared -1, any of these things, then you know that tells you, oh, we're using this one. When you see secant squared and tangent squared, that's when you use the secant tangent one. So it kind of, the more you see it and practice these, even if you don't have these memorized, like I only know the sine squared plus cosine squared equals 1. But as soon as I see it and then I kind of work with it, sometimes I just write sine squared plus cosine squared equals 1. And I say, okay, how can I get cosecant and a 1? So cosecant I know is, cosec, and I'm going to erase this, but cosecant is 1 over sine. So I know that I want this over sine squared, right? So because I want that, I just divide all these by sine squared. And I would get this identity here.
That's cool.
Okay, so I don't have these by any means memorized. Like I said, the core one is this one, and then you can really get anything. But okay, this was like scratch work on the side. Scratch. I'm doing more scratch. I'm trying to do more scratch work. I forget who it was last time, but they said it was helpful. Okay, so what this tells us is this is going to equal cotangent squared x. So now I have something real nice, because look, I have cotangent and cotangent here. So I'm going to factor cotangent x out of the top and then simplify. So let's do this. So I'm going to get cotangent x times cosecant x plus 1 over cotangent squared x. And now, well, at first I thought, oh, this is really complicated. But now I see it's looking a lot like what we want, that right-hand side. So I can cancel this out and cancel one of these. And then I'm going to get, this is the left-hand side, right? Remember, we still have cosecant x plus 1 divided by cotangent x. And this is exactly equal to the right-hand side, and we've just verified. So we're feeling good. Oh, and I see we have one more. So now we're mixed. Ooh, this next one is mixing in some log stuff. So this, your homework must have some of this in it, which is why we bring it up. But so the last verify is trig mixed with logs. So, and those absolute values, don't really worry about that. They're just there because you could have a negative, like sine and cosine, they could be negative, but take log of a value. So they just always, whenever you have logs of trig functions, you always are taking absolute value. But this is nothing to stress about. Okay, so let's give it a go here. So keep in mind, these are just some reminders that log base A of m plus log base A of n, these are properties of logs, is log base A of m times n, and log base A of m minus log base A of n is log base A of M divided by N. This is just a reminder, because I think, you've worked with logs before, and you could replace this with, you could replace it with ln as well. Okay. So now let's do this and let's tackle this problem. Let's look at the left-hand side. So that's this whole side, because this side is a little simpler. So we'll try to get that, the right-hand side. Okay. So I know I see a minus and I see a plus, which means I'm going to have, well, okay, maybe we'll just do one step at a time for people. So I'm going to have ln of absolute value of sine x over cosine x. Well, and technically it's absolute value of sine over absolute value of cosine. So that's this piece right here. Then we still have plus ln cosecant x. We'll get there. So now we can combine these two into one ln to get its multiplication. So we have sine x over cosine x times the absolute value of cosecant x, right? And maybe now I'll write, I'll change cosecant, like now I'll change it to sine and cosine so we can try to cancel some things out. You could have put sine and cosine as tangent, but then you'd probably want to change it back. So let's try to figure that out. So this is going to equal natural log absolute value of sine x over absolute value of cosine x times, now remember, cosecant x is 1 over sine x, right? So this is 1 over the absolute value of sine x. And now look how nice this is. These cancel out for us. Ooh. All right, sorry. It's annoying that this pops up, but these cancel out for us, and we're gonna get just natural log of 1 over the absolute value of cosine x. And remember, 1 over cosine x. So when you get this far, at first I think like, am I done? What's going on? Check the right-hand side when you get this far. And yeah, you're right there. So the left-hand side, you get that it equals ln of secant x, because that's 1 over cosine. And this equals the right-hand side. And you verified. And I guess, I mean, you don't need to keep rewriting left-hand side, but if you start with the left-hand side and then say, and then you go along, you start with the left-hand side and you go equals the right-hand side, that's kind of what I'm looking for. Sometimes they put it like the book or something, it'll do step by step. So it has like an arrow and it's saying, here's the left-hand side, here's it again here. I mean, it's the same thing. Okay. So this is verifying. These are, I think it's really important that, I won't say too much, but these steps, the rules and guidelines are helpful. The guidelines specifically are more helpful, I'd say. And knowing this chart, so whatever page of your notes, like this summary of the identities, I would say use, like refer to this when you're doing your homework, or refer to this when you're studying, or because the more you look at it, the more you're going to just have it in your head, and get it correct when you're thinking of it on the test or a quiz or something, right? Okay. So what we're doing next, or the last thing for today, and then I will discuss, there were book problems. I changed all of the homework. Did people here? Maybe I'll make a note here. I changed the homework to be due today. It was due before class, right? Instead of Sunday. So if nobody noticed, you probably submitted by Sunday if you didn't notice. But from Sunday, last Sunday to today before class. And okay. And if you thought it was due at midnight, yeah, I posted something in Blackboard, but I think I will end class probably early today because we're already towards the end. And so I can go in and extend it if you want to work on it after class. But typically homeworks are due Sundays, right, for the week. But if I ever extend it, like I did like this time, it will be to the Tuesday before class. Okay. So just so you know, for future, but I can't remember if I extended this week's to next Tuesday or not. But I think I kept, I think homework 6-1 and 6-2 are still, I think, due Sunday. I mean, you can check, right? Yeah, due Sunday, but I might have extended 6-3 to due Tuesday. I might have. If I didn't and you want this, just email me and I'll do it. But I think I did, and maybe I didn't, but I thought I did. Because I wasn't sure if we'd get to it, but we actually are definitely going to get to it. We're staying on schedule and we're good to go. And hopefully I am able to initially I wanted to give breaks in the middle of class, but I also like the idea of ending class a little early and allowing for questions and then everybody having a good night, right? Because it's just a long day and night for all of us, I think. But I'll mix it up and do both. But I just want to make that announcement about homework for those of you that saw it or didn't see it, right? Okay. So the last thing we're doing today is writing an algebraic expression as a trig expression. Okay. So looking at this right triangle, I think Pythagorean theorem, this squared equals this squared plus this squared. Or maybe I think, this sine is opposite over hypotenuse or cosine is adjacent over hypotenuse. Maybe I think of all of those things, right? But if we want to write this as an algebraic expression or write it with trig, this is nothing new. This is just what is tangent of theta. Okay. So remember tangent, this is and maybe I should have started class again with that song to remind us, but I'm sure it's all in your head anyway now. So you can just bounce around singing it. So tangent is going to be opposite over adjacent. And so here's our angle. This is opposite adjacent hypotenuse, right? So I can write tangent of theta is x over 2. And that is all we're doing for now. But in number 4, I think we'll do a little more solving. But then secant of theta, remember secant 1 over cosine, and cosine is adjacent over hypotenuse. So think reciprocal. So secant is hypotenuse over adjacent. So this is going to be square root of x squared plus 4 all divided by adjacent, which is 2. Okay, so now the next one is actually solving. This was just write it as an equation or an expression, and that was simple, right? We all SOHCAHTOA, we can all do this. But yeah, this, I don't know if Miguel is saying that this is crazy, or maybe you were talking about the song being stuck in your head. I'm sorry. So now we want to write this as a function of theta. So we're specifically, in this case, they're looking at theta between 0 and pi over 2, just because, we're looking at the first quadrant. So this is technically, think of first quadrant. That's just what they're choosing here, right? And you can see the way the triangle is drawn, it looks like it would be in the first quadrant if I was like making a unit circle from that. Okay, so part A says square root of 16 minus x squared. Substitute x is 4 sine theta. Okay, so this is gonna look weird at first, but then it's gonna be okay. So I have square root. So in place of x, I'm putting this whole thing, right? So I'm putting 16 minus 4 sine theta squared. Okay. So now I want to simplify. So I'm going to write it and then I'm going to simplify. So this is the same thing as square root of 16 minus, 4 squared, which is 16 times sine squared theta. I just put in that little squared, right? But now something even crazier that I can do is factor. So I'll write factor out the 16. And so this is going to be the square root of 16 times 1 minus sine squared theta, right? And I know that, so based on square roots, if you don't remember, this is the same thing as square root of 16 times square root of 1 minus sine. I'm writing a lot of extra steps, but this is for those of you that need it. You could skip some of these, right? So this is going to be the same thing as 4, because that's square root of 16, then times the square root of 1 minus sine squared theta, which, remember, this looks to me like a trig identity, and this should be, right? So this should be a trig identity. And we know it is, because we know that sine squared plus cosine squared equals 1. And so if I subtract sine squared, then I'm going to actually get that this is equal to 4 times the square root of cosine squared theta. Because this, this inside is equal to just cosine squared theta, right? And now the square root of cosine squared, is just cosine. So this actually equals 4 cosine theta, which, whoa, like weird. It's a little trippy. But we're just rewriting. It would be weird to think about. It's weird to think about substituting like algebraic expressions with trig expressions, but that's what we're doing. So if you look at like the above, if I multiplied in this case here, if I multiply both sides by 2, I get 2 tan theta equals x, right? And then if I was given like some algebra equation and they said, oh, but x is 2 tan theta, you could plug that in and then simplify it in terms of theta instead of x. So say you had no idea what x or any of this was, but you did have an idea what theta was or how to find it. Sometimes problems prefer, like, we can manipulate it so that it's written in terms of theta instead of x's. That's basically what's happening. We just changed this expression to have theta in it instead of x, right? By using substitution. So let's try this next one. And I promise.
Can I ask you a question? So how
yeah,
can you that? So that should be between 0 and n halves or whatever. Or no, I'm sorry, pi halves.
Pi
So
half. Yes, yes.
it should be in the
Yes.
first quadrant.
So
how can you-
this, right?
Mhm.
Oops. Oh my goodness. So this here, like this theta here, is still gonna follow the 0 to pi over 2, which just means that like it'll always be positive, right? And it'll be whatever those, yeah. So if there was more to the question, this would be more relevant. But right now, they just say it because you need to specify which quadrant you're in. That's all for theta.
Okay. And it's positive. So
Yeah, right, exactly.
Gotcha.
Okay, so now we're gonna write this last one. So we have x is 3 tangent theta. So everywhere that I see x, I'm gonna write 3 tangent theta. So 3 tan theta, and it's squared plus 9, all divided by 3 tan theta, right? So, sorry. Okay. And so now we want to just kind of rewrite and simplify. So basically, I mean, what we're doing here and here is converting all x to theta, then simplify. Okay, and Scooby's not having it. Hey, no. Okay. So everybody hide your pets or whatever. Okay, so then this is going to be square root of 3 squared, which is 9, tangent squared theta plus 9 over 3 tan theta. And this should always happen. Okay, give me just a moment. Okay. So this should always happen, that when you have a problem like this, I mean, they're going to be set up nice for you. Otherwise, like it's just messier to make it in terms of theta, which sure you could, but then there's no simplifying and there's no work to be done. So that's not that that's boring, just that, okay, then you don't need to do anything. So it's not showing much skill, I guess we'll say. So here we know, similarly to how we factored out 16, we can factor out 9 and get square root of 9 and then tangent squared theta plus 1, and then divide this by 3 tangent theta, right? And so here we can see square root of 9 is 3. So I won't write it like the way that I wrote this. I'm not going to write it like that again, but just know that you can take square root of 9 and then multiply by square root of this, right? So I'm going to get, I'm here. Okay. So now I'm going to get 3, which is the square root of 9, times the square root of tangent squared theta plus 1, all divided by 3 tangent theta. And I already see, okay, how nice, these 3's cancel. So, I mean, they don't need to, but that's nice. And then I also notice, that this right here, tan squared theta plus 1, this has to be one of my identities. So this is one of my Pythagorean identities, and it's the one, let me just scroll up to write it out for you. Tangent plus 1, I just didn't remember the order. So this one is tangent squared x plus 1 equals secant squared x. Okay, so it's exactly the way we want it. And, oh, except instead of x, it should be theta, right? But like same thing. So this is going to become secant squared. So this is just square root of secant squared theta over tan theta, which is secant theta over tangent theta. Which, okay, now I know I have to write sine and cosine. And okay, maybe we're going to get a little, I shouldn't have written the identity here, but we're going to write it here and say secant is 1 over cosine theta. And then tangent is sine over cosine. So it's a fraction over a fraction. So this is 1 over cosine theta times, and then the reciprocal, right? And now I see, okay, this is nice. The cosines cancel. I'm left with 1 over sine theta, which is just cosecant theta. And again, we get something nice, similar to, something nice here, that this crazy, so another reason that you could do this is because this crazy square root fraction guy, that would be hard to really do much with, it simplifies in terms of theta to just cosecant of theta in this situation, if x was 3 tan theta. So when it simplifies to this, it's much easier to work with the cosecant of theta than with square root of x squared plus 9 over x, right? So this is another thing that down the road, and again, well, you'd see it maybe more in calculus, but even in pre-calculus, some of the problems we solve might be just nicer if they're in terms of this theta, instead of in terms of x.
Very nice.
Yeah, it looks good, right? See, it's very, I would say this section is very satisfying. So it's not, you know, I mean, it could be difficult. There's stuff to memorize, the identities, you know, you got to take away the temptation of maybe cross multiplying and solving, and just verifying things. But, you know, it's very satisfying because you get to see these different things. And once it works out and you get the right-hand side, or, you know, you simplify to something nice, it just feels kind of good. And hopefully when you're doing your homework, that is how you feel. Let's hope. So, okay. So I'm going to say this before anything else happens, because.
So you mentioned you changed the homework deadline for last week, but you didn't change did you change the problems were assigned?
No.
For this
So
week?
I don't think I changed the problems. If for some reason I added problems or whatever, I mean, you can ignore it. It's fine. I don't think I changed any problems. I didn't mean to, if I did.
Okay.
So yeah, so I had only changed the due date. And now that I'm done. Oh, now you're seeing all my notes. How do I, hold on, give me a moment to just stop. Did anyone need to go back to those? Any objection? No. We're good. Oh, question of the day. I can ask you while we're here. Today, I'm going to ask, if you were an animal, which animal would you be? I mean, it could be down to like an insect or like a cat, dog, or a dinosaur. Like, I don't, you know, whatever. I just like to think about that. I mean, I struggle with this because I feel like I'd be a kangaroo because I'm like very jumpy and like high energy, or like, well, I guess the Energizer Bunny is a bunny, but I was thinking it was a kangaroo. I don't know why. But yeah, so I should answer as well. It's not fair if I don't answer. But yeah, so give me your animals, what you'd be, or, you know, if you don't think you would be an animal, I don't know. But
Professor, I have a question about 3E.
Yes. Oh yes. Let me share again. Give me a moment. Share screen. Okay. Go ahead. You can start asking. Let me.
Okay, I'm just missed why you multiplied. So I get why you had the ln of sine over x, or sine of x over cosine of x, but why did you multiply it by ln of cosecant x when it was added, I guess, in the original equation?
Okay, sorry. Say this again. So, oh, this is not E. I'm looking at the wrong thing. I'm like, where are you getting this? Okay, so say that one more time. You get
Okay,
sine and
so-
cosine.
Yeah, I get why ln of sine of x over cosine of x. Like, I get why that's the way it is, but I didn't get why you multiplied by ln of cosecant when it's added in the first equation.
Okay, so because these properties, so addition, it's in a weird order. Normally, like all the addition is first and then the minus is last and you divide. But this is in a weird order, probably because you guys are smart and they're trying to challenge you. But this plus, like I did it in 2 steps. I could have done it all at once, and I could have said sine times cosecant divided by cosine.
Mm-hmm.
But I did it in 2 steps. So first, first I combined only these 2, right? And I did it here. Then I said, okay, I brought this down and I said, okay, there's a plus ln of cosecant. And so then I combined these 2. And to do that, I would take what's in here and it's a plus. So I multiply it, and maybe all the highlights are just like so confusing. So then it's a plus. So that's why I multiply it by what's inside here.
Okay.
did that answer your question?
Yeah, I think I kind of thought it was like that because, when you add like the logs, it's like multiplying, but
Yeah.
so I didn't know if
Well,
it was
it's
kind of
not-
like an understood like cosine of
Yeah.
x over 1.
Yeah, and oh
Okay.
yeah, it's like cosecant. Yeah, so think of it like
Yeah.
exactly. Think of it like cosecant over 1.
Okay.
And then if that helps you, that's good. And also if you don't like the LNs, like some people don't like, because all of these here could be LNs.
Mhm.
And if some people don't like that, they just want log. So you could always rewrite it with like log over all of these.
Okay.
And then at the very end, I mean,
Change it
write
back.
LN if you need, but so that also might help just
Okay.
in terms of
Yeah, I definitely for some reason had problems with the LN in my last class instead
Okay.
of logs for whatever reason, but yeah, okay.
Yeah, so that is something good to note that like, I mean, unless you're solving for ln, you need a base e. Like, but
Mhm.
ln, you could also rewrite it as log base e. So if you preferred the whole log notation, you could literally just write log base e, and I don't care. It's the same thing. So if that's nicer for you, that's perfectly fine.
Okay. Thank you.
Yeah, thanks for the question. Other questions, I guess, before I rudely, or now I'm gonna, oh shoot, I think it'll save if I rewrote on it. Oh, yeah. Okay. Okay, cool.
Question.
Yeah.
So, I've heard you talking about Desmos, and I tried it out with the homeworks, and I love it. So
Good.
I was curious if we could use that during the test.
So for the test, I mean, I'll check. Actually, I think so, yes, because if a graphing calculator is allowed, you could use Desmos because it's the same thing as a graphing calculator. Granted, it's nicer, or to me, it's nicer because it's like it does the window, like
It's like
easier
10
to
times
navigate.
easier to use.
Yeah, I agree. So if actually, and I can double check. Let me stop sharing this now and pull up. I have the next test prepared, so I can tell you if would it be test 2 or 3? It's test 2, right? Okay, yeah, it's test 2. Oh yeah, allowed sign. Yeah, so you are allowed either a scientific or a graphing calculator, and so you can use Desmos for sure. Yeah, I
Okay,
would be
perfect.
fine with that. Yep.
Awesome, thank you.
Yeah. And let me just get out of here. Okay, I also have that, but I mean, it's on the syllabus somewhere, but
2 weeks.
I think it's in 2 weeks.
Mm.
Okay.
Not
And is
next week, but the week after.
Yeah. Okay. So it's the 13th. It's October 13th. Does that sound right?
Mhm.
Yeah. Okay. So it's October 13th. So it's 2 weeks from this Thursday. So that means that 2 weeks from today we'll be reviewing. And I did, well, I'm working now on the third test, but yeah. Oh, thank you, Brian. I was like, what's 1013? I literally just said it. Okay. Yes. So that is when the next test is. And I will say I have to double check, but I am giving a quiz before the next test. I did get it together a little bit. However, I don't remember the date of it. So let me actually log into Blackboard because I can tell you the date it'll release. I think it's either this week or next, like it's either Thursday, like this week or next week. But also there was another question that I was going to check on Blackboard or something. Does anyone remember? Sorry, I have to verify my code, of course, because Blackboard kicks me out every 2 seconds.
You were talking about giving some more time for the homework.
The homework. I was going to check when it's due. So let me, because would people prefer Tuesdays before class? Yeah. And if you have to go, thank you so much. Have a great night. We will, I'll stick around, but class is done. I'm going to just change the homework. But yeah, so instead of Sunday nights, I could make it due Tuesdays, but I would want to make it due Tuesday before class because we're going to start new material in class on Tuesday. So if this is okay, yeah, thanks, Joseph. Bye. So like